Alright, time for another new filament. This is, it's not completely new, it's from California Filament. They make PETG. And I've had super good luck with their black filament. And I have a new project coming up where I'm going to use gray. So I figured that's my go-to PETG, so I decided to try these guys. So the box is not super heavy duty, but it does well for protecting everything. As you've seen in my other reviews of California Filaments, they switched over to the cardboard reels, which is fine. It's better for recycling, I assume. It may be cheaper to produce. I don't know. Their prices haven't gone down any, so I don't know about that. There is some extra friction with this, but we have our filler compatible reel holder reels that spin around, so there's no problem with friction on our setup. So. Anyway, pretty good vacuum on this. It's got a silica gel packet on the inside. It says it prints from 230 to 250. We've had really good luck with this filament at 237 on our flash forged printers. I'm going to be testing this on the NX printer today, even though I've upgraded the G2 because I've still got the NX around for doing prototyping and some small production runs where I need some extra capacity, but mostly I'm printing on the Guider 2 now. Anything else on the box we need to worry about? Not much. It's made in China, even though it's called California Filament. That's interesting. All right, let's open this up and then we'll weigh it. All right, let's open it up, see if we can hear a whoosh when we open it up. Nice whoosh there. That means I had a good vacuum. You can also tell by this center section is depressed. If it's sucked in, there's a good vacuum. Take a look at this color. So this is the color we're looking for on our project. It's kind of a medium gray color. It's going to be a good contrast. The main part of our project is white. I'll show you. I'm not sure if I'll put that on this video, but I'm coming out with a new product that's going to use mostly white PETG with some gray for accents. So. Silica packet, we'll save that and put it in our dry box for extra buffering capacity for moisture. So there's our reel. Let's go ahead and weigh it up and we'll see if we got our money's worth. All right, so I have an empty reel from a previous printing project. So you can see here, this is flattening out here, so this increases friction. So if you just have a post in here, as it widens out, it's going to get more friction. So it's probably not an issue, but something to think about. So put the empty reel on here first, turn on our scale. That's called tearing. It sets the zero that includes this weight of this thing. So then we know that, then we can measure the net weight of the filament. Supposed to get 1 kilogram. Let's see what we got. Now we got a little extra, 12 extra grams, which is interesting because I'm evaluating Sunlu as a replacement PETG for this California Filament because it's slightly cheaper and prints really well. And maybe not quite as good as this, but it prints really well so far. So we're evaluating that because it's about 20% cheaper. But they seem to be accurate within 1 gram on their real windings. So, and we got a little bit extra for our money, 12 grams extra. That's always good. It's better than going under. Some manufacturers say plus or minus 50 grams, which seems like a lot to me. It seems like you just reel it X number of times around and you're done. But anyway. So let's go ahead and we'll put this on the machine and we'll do our usual tests, our temperature tower and our bed and layer adhesion test. And I have a little fun print that we haven't done for a while to see if this does well on small details, because we're going to be having some small details printed with this, so we want to make sure that I can do small details in a reasonable fashion. So that's our fun test this time. Right, here's our favorite temperature tower. It's called the Pointy Temperature Tower. It's a project on Thingiverse. I remixed it and added this little lettering over here to say what kind of filament it is. This is PETG, so there's only room for PET on here. But in any case, there's a link to this in the show notes. This is OpenSCAD, and so you can easily modify it by changing the starting and ending temperature and the temperature step. So PETG, we print in the high 230s. Mostly, basically all the PETG we've been using so far, or recently anyway, has been printing at 237. That seems to work really well. Flows well and has good layer adhesion. You never know though, so that's why we're testing it. So this is our temperature tower test, and then we're going to put this into Simplify 3D
and slice it, and then send that over to the printer. Alright, here's our temperature tower project in the Simplify 3D. This is version 4. So I have version 5. I'm using it for more and more things, but I have a lot of projects still in version 4, and the conversion to version 5 had some issues, at least with the early versions of version 5. So it may work better now. I just haven't tried it lately. Any new projects I'm starting from scratch that aren't test projects, I will almost always start with version 5, unless there's something they haven't really translated over yet, like some of the bridging or the support stuff doesn't work quite as doesn't work the same. So I'm having some trouble with that. So I've been using a few version 4 projects, but mostly version 5. But anyway, in this case, we're using version 4. And for a temperature tower project, you need to set up a temperature gradient. Because let's just look at this again. So what we want to do is we want the lower layers to print at 239. Then when we get to here, we want to switch to 237, 235, and 233. So we need to have a temperature gradient. So Simplify 3D makes that really easy to do. So over here, you have your bed temperature. Now we're putting on the NX. And you'll see that we're using a new PEI surface I got. And that was a little slightly higher bed temperature than the Guider 2 because of the way it's set up. So Guider 2, we're normally printing PETG at 60 degrees bed temperature because of the way that removable PEI surface works. But the NX, you want to use 65. At least that's what we use so far. So then for the temperatures, we have a gradient. So layer 1, we start at our highest temperature at the bottom and work to a lower temperature. Because normally, higher temperatures, the filament will flow better at higher temperatures, and you could get clogs at lower temperatures. So you want to start at the highest temperature and go to the lowest temperature. You'll have better results. So we start at 239 at layer 1, and we keep going to layer 18. The first 17 layers are this base here. So I'm printing that at the same temperature. Then from 18 to 52, we're printing at 239, and then 53, layer 53 to layer 87, we're printing at 237, and so forth. So now for cooling, normally with PETG, I use either 5 or 10% fan at the second layer. Sometimes I skip the first 3 layers. Haven't done that lately. I can't remember what project that was for, but I found with and some of the tests I've done on our other filaments with 0 fan, it just doesn't get good results, because when you're printing this thing over here with no fan, it gets all blobby. So I've always had to use some fan. Some websites say PETG with no fan. That didn't work for me. Maybe it works for you. So 5% or 10%, and you'll see in this project, I mean in this process of testing this filament, we're going to have some issues with these parameters. So we're going to be playing around with this probably. That's just a preview of the coming attractions. But for now, we're going to use our standard gradient here, and we're going to use our standard cooling, which is 10%. That gives good results and good layer adhesion on other PETG filament I'm printing. So, all right, so we'll send this to the printer and look at the time lapse.
Like I mentioned earlier, our reel holder is this spinning. It's called filler rather. That's what the original name on Thingiverse. So I've shown how I print this in other videos. You can look those up. Mainly it uses a skateboard bearings on the side here, so it spins real smooth. So with cardboard reels, there's no problem getting them to spin easily. So, all right, we'll load this up and then we'll see how it does. This is our new setup with the NX with a removable PEI surface. I've shown that in another video where I tested it, and it works like a dream. So stuff just comes off. You don't have to use a spatula. You just flex this plate and it comes right off. And also the benefit of that is I used to have to use a spatula on this printer to remove things, and that would, because of the quality of this is lower than the G2. The spring-loaded leveling nuts here would get jostled, and it would get out of level almost every time. So I have to level up through every print. Now, in between prints, it hardly changes at all. Normally I don't have to adjust the level at all, but I still always level once at the beginning of the day. This is my first print of the day on the NX, so I'm going to go ahead and level it. But if it's like it has been recently, I've been using this a couple weeks now, I haven't had to change the level at all. It's a little bit, yeah, it's a little bit too loose. I'll just tighten it up a teeny bit. With PETG, you don't want to smash it down on the surface as much as PLA. So I could use a little bit of, just a teeny bit. Oops, the other way. There. Teeny bit of tightening. Probably didn't really matter, but so this one little, maybe 1/16 of a turn. All right, filament's loading. Let's see how it does here. Let's see if we can get a background of this. Yeah, that's better. Nice smooth flow. We like that. So that tells me the extruder temperature is good, which is what I expected. I mean, their filaments all. I mean, I've only used black so far. So their filament always flows super easy at 237. The black filament does anyway. So I'm assuming. I guess I assume this would be the same, and so far it looks like it is. All right, now for PETG, we printed it all buttoned up. So we're going to put the top on, push it down. So PETG, we print all buttoned up. With PLA, we open up the top and or the door as it gets hotter. So we'll go ahead and start our temperature tower, and we'll just go from there with the other tests. Let's see how we did. This just comes off, it's magnetic. It's our string. Looks pretty good. Let's take our white move off. Let's flex this. Pops right up. Alright, so really great printing all up and down. As usual, the California Filaments is super good PETG. Almost no drooping at all on any of the bridges. A little bit of drooping at 237, so 233, possibly slightly better. Basically no drooping. And the pointy towers on the end here are all good at all temperatures. So anyways, this will print at a wide range of temperatures, looks like. So we've been printing everything at 237. I'm going to stick with that for this filament. And we'll see how it does on our more highly detailed front print and see if it can handle that. Based on this pointy feature over on this side, I think it's going to do fine. So it looks like our cooling, which is 10% after the first layer, is working. Again, we're going to go through our standard test. The next test is the bed and layer adhesion test. So you saw there was good layer adhesion there. The bottom looks perfect, but just better to test everything. Maybe this is the first video of mine you've watched, but I always do those first two tests. That's good. The temperature tower, and then the bed and layer adhesion test to make sure I've got my cooling dialed in and got good layer adhesion. Without layer adhesion, you have a big mess. So, all right. So our printer's up to temperature again. So we'll go ahead and start the new print. Now, before I do a new print with the same filament, I always run an unload filament cycle, because that will make sure the filament's flowing well through the nozzle before you start the next test. Because it takes a minute or two to heat everything back up again after the print finishes. Especially on the guider too, the NX is so small that it finishes quickly, and you can get to the keypad here and turn on the preheat again before it cools down very much. On the guider too, it takes forever to send the print bed down to the bottom of the printer because it's so much bigger. All right, so we'll go ahead and start our bed and layer adhesion test, and we'll see how that turns out. Oh, we're printing this at 0.2 millimeters layer heights. That's also, we did this at that. Because this particular stuff, we went higher detail, so we're printing at 2.2 millimeters layer height, as opposed to some of the other PETG, we've been printing at 0.3 to print big projects. So it goes faster, but for this we want more detail, so we're going to print at 0.2 millimeter layer heights.
If you like this video, please give it a thumbs up. Post a comment if you have any questions or ideas, and I'll try to respond. That's all for now, but more videos are coming, and if you want to see them, please subscribe to my channel and turn on the notification icon if you don't want to miss one. This is Beta Cygni signing out, and keep looking up.